For number 13, it says refer to the figure, and I have three different ones. Really, this is three different examples. Which theorem guarantees M and N are parallel? Okay, so all we really have to do there is identify the angles that are being that are highlighted, like these two angles, right, and then these two angles. For example, this angle and this angle are both corresponding angles. Now in here it says which theorem guarantees that? Well, it's the corresponding angles theorem. Okay, I'll let you get away with just identifying them as corresponding angles. But let's look at the next example. In the next example, remember when we were doing these, and I said, hey, let's connect these lines, because then we have like an interior and the exterior, and we can talk about that. Well, these two angles are exterior. They're not on the inside. So I know part of the name is exterior angles. And then the next question is, are they on the same side of this line? This, I would say that's the left side, that's the right side. Because they're on different sides, these are alternate. Oh, be careful with that. Alternate exterior angles. And let me rewrite alternate, because I do want you guys to be able to spell it correctly. Alternates like this. Alternate. Okay, there, that's better. Alternate exterior angles. Again, because they're on different sides of the line and they're exterior to this band-aid shaped figure that I made. So same thing here. Connect these two. I know these angles are interior. And then if I compare them to this line, this is on the left side, that's the right side. So these are alternate interior angle theorem. And technically they're all theorems. Right, theorem. But again, you can get away with just knowing the name. Okay. And then for deductive, for these, you're pretty much going to have a statement, and then the question is going to be, is the statement an example of deductive reasoning or inductive reasoning? And this is what you want to look for. For deductive reasoning, you want to look for these keywords in the phrase. Or it's basically when you make a conclusion based on like facts, definition. Let's say sometimes they use math equations or a rule, policy, anything like that. And then for inductive reasoning, the conclusion or the conjecture is based on an observation that you made. If you saw something or if you've seen something, if you examine something, right, like a pattern, some data, anything like that. Okay. And then these are pretty much like the key terms that you may see inside the statement. So for 15, so we have this triangle. If we want to find the measure of angle x is a exterior angle to the triangle. And then I said, whenever you have, I think it's called the exterior angle theorem. The exterior angle theorem for a triangle tells us the outside angle will equal the sum of the two remote interior angles, or the two non-adjacent interior angles. It can't be the one next to it. It's got to be the two that are away from it. So if you add those up, you get 112. So that's the measure of x. And then y, there's actually different ways you can find y. I'm going to show you y this way first. So I know, let's say you cover this up. I know y pretty much looks like this. Y is inside a triangle that has these angle measures. Okay. And shoot, I can't remember the name, but the triangle angle sum conjecture tells us the three angles inside a triangle add up to 180. If I know two of them, this is how I find the third one. Subtract the two I know, and I'll be left with the one I'm looking for. Okay, so if you subtract those two, you get 68. So I know y is 68. So this is one method to find the value of y. Let me go back to my diagram over here. You know how I figured out x was 112? I could have said that's 112, and then these two angles together form a linear pair. So if I wanted to figure out y, I could have done this. I could have subtracted 112 and 180 and got 68. I like this method because it makes it well, this seems easy, right? But this also works. So if we look at 16, 16 is similar to 15. We have a triangle. This angle is 29 degrees. This angle up here, because of the square, is 90. And it's asking us to find the measure of angle XYZ. XYZ, if I follow the letters, is the outside angle, right? XYZ. So that tells me the measure of the exterior angle is equal to the measure of the two non-interior angles added up together. 90 plus 29. That's what you get, right? 119. And then the last one on this page is in a triangle, the measure of the largest angle is 109. I like to draw it. Now it's not to scale, just make yourself a triangle and then start putting in the measures that they give us. Okay. The first angle they tell us is 109. Doesn't matter where you put it. I'm just putting it down here. And then the second angle measure is 31. Again, it doesn't matter where you put it. I'm just putting it down there. And the question is, what's the measure of the remaining angle? So what would that one equal? Well, then it goes back to a problem like this one. Okay. We know the three angle measures together should equal 180. I know these two. If I subtract them, I'll be left with the angle measure I'm looking for, 40. 40 would be the angle measure of the remaining angle.